Okay, worksheet number 5. Worksheet number 5 is going to deal with your regression equations. Okay, so the first time you're doing this, you see it. The question says using x equals 1, representing the year 1986, and y representing the number of new stores, write the exponential regression equation. As soon as you see a regression equation, whether it's linear, exponential, power, log, you got to try to figure out a way to get the data into the calculator. So the way we get the data into the calculator, let me move this over for a second so you can see the data, you can see the calculator. Okay, we want to go stat. We want to go stat and then edit. And that brings your lists up. And your first set of data is going to be your L1, which is going to be your X, and that's going to be your year. It's always going to be, for this test, your X is always going to be the data listed first, and your Y is going to be the data listed second. So either left to right or top to bottom. In this case, it says X equals 1 represents 1986. So 1 is going to be 86, which means 2 is going to be 87, 3 is 88, 4 is 89, 5 is 90, 6 is 91, 7, 92, 8, 93, and 9, 94. And what you want is maybe just put that here so you remember what you put in case they ask you questions later. Okay, so there's your list 1. Your list 2 associated with 1986 is 14, and then 27, and then 48, and then 80, and then 110, 153, 261, 403, and 681. So that's your data. It's in. Okay, so they want a linear, exponential regression. So here's where your data's in. Make sure you check it to make sure everything's good. Then you're going to hit stat and now go over to calc. And you're going to move down until you see exponential regression. Alright, so just so you know, linear regression is either 4 or 8. Natural log regression, exponential regression. There it is. That's the one we want. Here's power. Alright, so we want exponential regression, so we hit enter. And then you got to tell the calculator where the data is. And if I move the calculator up so you can see, you know, above the number 1 is L1, above the number 2 is L2. So you got to tell it that the X variable is in L1 and the Y variable is L2. So I'm going to go second and then number 1, and you see L1 display. Then you have to put a comma between them, second, L2, or second 2, and you have it. Hit enter, and the calculator will tell you what the regression equation is going to be. So let me move this over, and then we can write this down so you can see what's going on. An exponential regression equation, the first line they'll give you is the formula for it. It's going to be y is equal to a times b to the x. That's the form. So they tell you what a is and they tell you what b is, but make sure you read the question. The question says we want everything to the nearest thousandth. Alright? So I'm going to switch over. So everything to the nearest thousandth. So y is equal to a, which is 10 point, and again, nearest thousandth, tenth, hundredth, thousandth. So it's be 596. Okay? And then that'll be times b raised to the x. B is going to be 1.58. The thousandth is a 6. It stays raised to the x. There is your linear regression, or not linear regression, but exponential regression equation. Alright, and then part B, so that's your A, and then your part B, reading the question now, forgive me, is going to be, if this pattern continued according to your answer from part A, predict the number of new stores in 1998. Well, if I keep going, 94 is 9, 95 would be 10, 96 would be 11, 97 would be 12, 98 would be 13. So if you wanted to, 1995, 1996, 1997, 1998, okay? So this is 10, 11, 12, 13. So they want 1998. So if they're going to want you to predict using your align, The way you do that is just in your calculator, type in your equation, 10.596 times 1.586 raised to the x. And the x in this case is 1998, which remember is going to be 13. Alright, hit enter, and you get 4,256 point, again, what they say, they don't give me, but again, if you want whole stores, there it is. Doesn't matter what the decimal point is, you're not going to round up. That's the number of stores you're going to have. Alright, next question is part C, I guess. It says write a linear regression equation or a least square regression equation for the data. So least square regression equation, we go back to the calculator. We're going to go stat, calc, and I'm looking for linear regression. There it is. L-I-N-R-E-G, that's linear regression. Hit enter, and then where's the data? L1, comma, L2. Hit enter, and once again, in reading this, your linear regression equation is in the form y equals ax plus b. So it's going to be y is equal to, and again, let's round it to the nearest tenth. All right, 71.58, so 71.6x, because that's in front of the x, that's the a, and the b, minus 160.5. Right, and it says predict the number of stores predicted by the equation you came up with in C in 2001. So now we're going to keep going. So we'll come back up here. 1998, 1999 is 14, 2000 is 15, 2001 is 16, and that's what they want. So they want to know in 2001, which is 16. So again, there's your linear regression equation. So with your calculator, you're going to clear this out, and you're going to go 71.6 times x. Now x is going to be at 2001, which is 16, all right, minus 160.5, and it gets 985 stores. Okay. And then finally, they want the logarithmic regression equation, and actually we're going to change this from log to power. Alright, so we want power. So once again, we're going to go to the calculator, we're going to go second and then calc. Or sorry, I'm not going to go second yet, we're going to go stat, calc, and we're going to look for power. So we go down until we find the power regression, there it is. Okay, hit enter. And we're going to search for L1, comma, L2, hit enter, and we get our equation, and this time it's in the form y is equal to a times x raised to the b. Alright, so y is equal to 9 point, let's say I want it to the nearest thousandth again, so y is equal to taking the calculator to the nearest thousandth, we get 9.349. 9.349 times x raised to the b, which would be 1.710 if we rounded. Okay, so there's my regression equation, I guess. And then part E says, using your answer predict for 1996. If I go back to 1996 was year 11. So this is what I want to evaluate, 9.349, 11 raised to the 1.710. So I use the calculator to do that, 9.349 times 11 raised to the 1.710, enter. I get 564.34 stores, so 564 stores. Right? And that's worksheet number 5.